It is very easy to find the electric field at a point due to a point charge, whereas if it is a distribution of charge, it is quite difficult because that charge distribution consists of many number of charges. So you have to find the electric field due to single one charge, and you have to continue it, and this creates a lot of difficulty, complexity in solving. And Gauss, a scientist, discovered a relationship. That means for symmetrical charge distribution there is a easy way to find the electric field at a point, and this is in the Gauss law says that the total electric flux through any closed surface is 1 by epsilon 0 times the charge enclosed by the closed surface. It can be any closed surface. I take any closed surface, and if you have a charge q here, and through this closed surface, actually this is not a curve, closed curve, but this represents a surface. This is not 2D, this is a 3D. And suppose this is a charge q in the surface, and through the whole surface, for example a football like surface, it is a closed spherical surface or a closed cylinder, any closed surface, and the flux through these closed surface, that is E dot A. But here the problem is the electric field is not same at all points of this surface. So we have to take a small area where the electric field is E. You have to integrate this through the whole surface, which will give you the total flux. So according to this Gauss law, the total flux through any closed surface is equal to q by epsilon 0. The advantage of this Gauss law is that we can find the electric field due to symmetrical charge distribution. The surface which is considered to use Gauss law is Gaussian surface. We have to imagine a surface which is symmetrical to the given charge distribution. What do you mean by this? It means that the surface which you consider has got the electric field value same at all points on the surface. So we know the area of that symmetrical surface, and we can find out E into A, where area is known because electric field is same at all points of the known area, which is nothing but q by epsilon 0, where q is the charge which is enclosed in that closed surface. And by this method we can find the electric field due to a line charge or a plate or plane sheet of charge or a charge due to a spherical shell or a sphere, charged sphere. In this case of line charge, you imagine a cylindrical spherical surface. This line charge has got the value of lambda L, where this is length of this Gaussian surface is L, where I use the curved surface of this cylinder, where the electric field passes through only the curved surface because the lines of force are radially outward. So we know the curved surface area, that is 2 pi r L, that into electric field is equal to the charge is lambda L by epsilon 0, where we will get the value of electric field as lambda by 2 pi r epsilon naught. So easily we got the value of electric field of this continuous charge distribution, but the condition is it should be symmetrical. Symmetrical means the distribution of charge should have the same geometry, and so that you can imagine a surface which is a Gaussian surface where all points of that Gaussian surface will have the same value of electric field. Similarly, in this plane sheet of charge, here also we imagine the Gaussian surface to be some closed cylinder. In this case the electric field are outward in both directions, and only the end faces will get the electric field. The curved surface do not get the electric field. So this area is A, this area is A. The total area where the electric field is there is 2A into E be the electric field that I have to find out. the charge enclosed is sigma A, where sigma is the surface charge density by epsilon naught. So again we got the value of electric field as sigma by 2 epsilon naught. And similarly we can find the value of electric field due to a shell. In this outside point, the electric field will be kq by r square, where q is the charge in this shell. In this point the electric field is 0 because any Gaussian surface do not enclose any charge inside the shell, and on the surface of the shell the electric field is same as kq by r square, where r is the radius. So this is for the outside point, this is for the surface, electric field at the surface, and the electric field is 0 at an inner point. Thus Gauss law plays or helps us in a great way to find out the electric field due to symmetrical charge distributions.